Okay, so this will be dP equals dP1 plus dP2 plus dP3. And multiplying and dividing it by dG over dG, dt over dt, and dN over dN, which will give me an equation that is dP equals partial P over partial T dG plus partial P over partial T dt partial P over partial N. Okay, so for first one, it would be partial P over partial G. Now, I don't have anything else, but I do know the units for N. I know units for P are newtons per meters squared, and G is joules. And I know joules are Newton meters. So newtons will get canceled, and I only have 1 over meter cubed, which means it is 1 over V. You can do the same thing to the next one, the dP over dt. But what will you do with P? Multiply and divide with certain things. So we can do partial P over partial T. Can this become, I need to get rid of the T. The only way I know to get rid of the T is to put it in terms of entropy. Because entropy is Q over T. So if I can just figure out how to get entropy in it, I can get rid of the T. Okay, so how do I do that? This is newtons per meter squared divided by T. I can rewrite this as newtons per meter squared T. Can I multiply and divide by M, which will give me joules per meter cubed T. Now, this part will become S. And meter cube is just volume. And the last one is tricky because it has an N in it. And somehow I have to get rid of that N. So I will have to do double the tricks in here in order to get rid of it. So what are the 2 tricks I'm going to do? So you may want to watch this one. So the last one will be dP over dN, which I can multiply and divide with S. So now some magic will happen. Focusing in on this one. So this one is easy. What's the answer for that part?
-U.
From what equation?
1C.
1C. Or 3C's, right? This one is hard. Note what's going on. P is newtons per meter, and S is joules per T. This is now newtons per meter squared divided by Newton meters per T. Did you see that? That means newtons will go away. T can be rearranged to be brought to the top, divided by m cubed. And what is m cubed? If nothing other than T over V. So what I will get, in fact, is T over V and minus mu over T. So the T's cancel out, and I am left with minus mu over V. This is why the U wouldn't have worked, Nick. Because there will be a T that pops up, and then there's nothing we can do about that. But S will work because it inherently has a T in it. Yes?
The T over ds 3D.
I know the other one.
No, the T over ds.
dp over ds is 7.
Isn't it 3D and you can flip it?
Oh, is it?
Yeah, we have that.
Oh, wonderful.
It's 3D.
It's 3V. And it still gives you P over V?
Yeah, you just flip it.
Yay.
So much faster.
I mean, this is also a fun way to do it. But yes, you're right. You may have an equation that's there.
I kind of like what you did first.
I mean, I can erase this one.
No,
No. Again, there is no need to erase anything. You're saying you have infinite space.
Multiple ways.
Multiple ways to solve it, but okay. So then what do we do next? We have all of these values. What are we going to do with them?
Put them back in.
Put them back in. And what do we get? dP equals, what is it? 1 over V dg plus S over V dt plus, no, minus U over V dN. Am I missing anything? No, we're good. So V's on all the sides can go on to the other place. Vg plus SVT minus mu dN, or dg will just be VdP plus SVT minus mu dN. Yay! Now, in chemistry, you guys will do a specific situation of all of these thermodynamical potential that we have done. And those are called Maxwell's relations. They are solved for you in example 10.1. But we are not going to do them in class. Yes.
How are you moving VDP without the sign switching?
Okay, actually this,
negative flip side, we'll have to flip everything else too.
yeah,
SCT will become negative.
yeah, this will become negative.
And you then become positive.
Yeah.